Good afternoon, everybody. We're going to introduce a topic with this video that's going to take us into our next unit, which is on forces. I love getting into this part of the course because we've only talked so far about the descriptions of motion for objects, which is really, really important, and we'll use it all year long. But we now get to talk about why kinds of motion happens, which is where things get really interesting. So we're going to do a little bit of language norming right now. We're going to talk about some of the forces that you may or may not have heard of. Basically want to make sure that the language we use together is one that is consistent, because force is a word that's used all over the place. It's a common word in pop culture, and it's something that we need to make sure as physicists we norm in our physics class, so we're all talking about the same thing. So it'd be wise, of course, as usual, to write down some notes as we go through this. Something we will do over the course of the next couple days is to clarify a little bit more what I'm going to talk about, and then we'll get into some more concrete descriptions over the next couple weeks. So the first place we're going to start is just the basic definition of a force. We're going to refer to a force as a very simple definition, an interaction between two objects. So a force exists when we have two objects, and in some way they are interacting with each other. And so there's lots of ways we can describe that. Let's go through a couple of the ones that are a little bit more obvious, and then we'll kind of back away to summarize this together. So I put gravity on here as the first one because I think it's the one we have most often talked about in class. It's the one that's, I think, most common and referred to. But let's talk a little bit about what gravity is. For us, gravity is going to be a force of attraction between two objects. I don't want to go too far into what gravity is at the largest scales, because that's sort of outside the realm of what you have maybe learned about so far. I think it's wise for us to just focus on what we'll call local gravity, which is just the gravity experienced by us on the surface of the Earth, very close to it. And later in the course, we're going to talk about universal kind of gravity, the kind of gravity that, as we read about with Neil deGrasse Tyson's ballistic chapter, governs the orbits of planets. So there's two types of gravity, but they're not different types. They're two ways of thinking about gravity. We're going to think about it primarily, to begin with, as local. And it is a pull between two objects. We're going to think mostly right now about a very large object like the Earth pulling on us. And that gives us right now a direction for gravity that we can define as being towards the center of the Earth. So we could say here, towards Earth's center, which for our cases will be down. And that's straight down, perpendicular to the surface of the Earth, straight down towards the center. The next force is called the normal force, and this is a word that you may have come across, but not in this context. Normal in physics and math world means perpendicular. So when you come across this one day in a math class and someone says normal, what they actually mean there is to a 90-degree angle to some other surface. But this is really what we're going to call the push force. So when people think about a force as something that could be pushing another object, so two objects interacting in that way, we would call that the normal force or the push force. So there's lots of ways this can look. A normal force could be as simple as me pushing on this board. The push of my hand against the board is perpendicular to the board. It's pushing into the board, is one example of the normal force. If I look down where my chair is sitting right now, the chair is pushing down on the ground. That push down on the ground is another example of the normal force. It's perpendicular to the ground. If you have a computer in front of you and it's sitting on a desk, it's pushing down into that desk, perpendicular to that surface. It's pushing down. We would call that the normal force. And so the direction for the normal force is always perpendicular to the surface. This means that if a surface that something is sitting on is tilted, that the normal force will still be perpendicular to that tilt in the surface, which is where the name normal force comes from. So you can think of normal force as the push force. Let's go to three other forces that will start with, friction is another common force that you've heard of before. We're going to talk about several different kinds of friction. Two of them are ones that you've encountered before. But before we do that, I want to talk a little bit about what happens to cause friction. Friction, we can also talk about as what we'll say is a shear force. Now, you might not have come across the word shear before, but if you think about one of the ways in which we use the word shear, it's to describe an object, a pair of shears or scissors. And the way scissors work is by having two pieces of metal that slide across one another, like this. And so those two pieces of metal are shearing against one another. That's a description of an action that is present when we look at the interaction between two surfaces that are experiencing friction between one another. So let's do a couple examples. So one example of friction I could have would be if I took my two hands and sort of moved them back and forth across one another. This, if I looked at the microscopic level of the surface of my hands, what I would see are, if my fingertips now can represent the molecules or the atoms on the surface of my hands, as they move past one another, they sort of sometimes interlock and kind of have to move over top of one another. In other words, interact with one another. And to the degree that that motion exists, or those interlock patterns happen over and over again, we can get more or less friction. And so that's the shearing that's happening. And if we were to look at the surface, we would actually see those molecules sort of moving back and forth to kind of allow one object to move past another. So this is the example of a shear force, or the frictional force. So the one example we can have is, of course, moving objects next to one another. But there's another version of friction that happens here, which is the kind of friction that happens when the objects are not moving. So I can actually push my hands in different directions right now, but not let them move because of the amount of friction that exists there. This would be the idea of if I wanted to push my board here across this tray, I'm applying a pressure to the board, but it's not moving yet. And that's because the friction between the board and this tray is bigger than the amount of push that I'm applying. If I overcome that though and I push hard enough, what will happen is eventually it'll start to slide. And so that's another kind of friction, the friction that happens between two objects that aren't moving next to one another. Friction, as it has a direction associated with it, is always parallel to the motion of the objects, or parallel to the surface between those two objects. So we're going to write it like this. So it's parallel to the surface between the two objects. So if I were pushing across like this and watching the board slide across, the direction of friction here would be back this way because it is parallel to the surface. I should also say here the direction it is resistive, in that it moves in the opposite, it points in the opposite direction of the motion of the two objects along that surface. So that's friction. Tension forces are forces that are present when we have an object that you might describe as pulling another object. And so this is the pull force that you might see as different than the push force from the normal force. And so there's lots of things that can have a tension force inside them. We could think about this as a string that you've attached to a box and you want to pull the box towards you, so you pull on the string. The force that we describe through the string is what we'd call the tension force. We could talk about my arm pulling on a drawer to open it up, and there's a tension force along my arm that is causing the force on the drawer as I try to open it. And so tension forces and pulls are present in objects that can sort of be extended. The thing that has to be true though is this: the object that you're talking about has to be taut, meaning that it is stretched. In other words, a string just simply laying on the ground, not being pulled, doesn't have a force in it. It's not until you pull it all the way till it is taut or tight that it has a force within it. And so this is the way in which we know that there's a force present there. And the direction here, if you think about lots of different scenarios, you can eventually come up with the direction to be along the, I'm going to say string, just to like reduce it to the many different kinds of objects that we could have, because it doesn't have to just be a string. You could have yarn, you could have a spring, which we're going to talk about in just a second. You could have think about someone's arm. There are many different places that we could go to think about this. We're going to kind of reduce them all to say it's just along the direction of the string or whatever the object is. The final force we're going to talk about here early on is a spring force, and this will be one that we dive into later in this unit a little bit more in depth. But spring forces are very similar to tension forces in that they're present in elastic objects that have the ability to stretch or compress. Okay, so the important piece of reasoning you have to think about is something that can compress or stretch. So two really good examples to kind of think about when you do this are, so for the stretch case, I like to think about rubber bands, because they're sort of everyday objects that we can think about, but a stretched rubber band causes a force because of its stretch, being stretched like that. The compress example, the one that I think is most common, or the one that I think about the most as an easy example, is if you've ever taken apart a mechanical pencil and you look at the spring on the inside, that spring is one that when you compress it, you can feel that there's a force being applied. That's the actual compression that you get when you click your mechanical pencil. And for both kinds of spring action, compression or stretching, the direction is always along the spring. And so that will be the way in which we can get an access to what direction the force is caused by. So those are our 5 first forces that we're going to start to talk about. What you need to be responsible for so far is this. You should be able to name each type of force. You should be able to tell us about the conditions that are necessary for each type of force, and then you want to be able to talk about the direction of each kind of force. Those are the first level skills that will start to apply as we start to analyze the world and the forces that happen on different objects. Okay? So make sure you have your notes ready for tomorrow. We will wrap up our structures in class, our art structures, and then we will start to talk about forces.